Okay, welcome to the next video. This is Oratemos on the video. So now we'll be doing more questions on the integration of exponential and logarithmic functions. I will feel that it's always better if you have more examples that you can work with. So let us dive right into it. So let us say we now had a question like E. Just a reminder, this table on this side helps us solve these types of questions that we have, and we can look at how we could do this. So this will be a good example where we can use the U substitution. So we will let U equals to e to the x plus 2. And if we had to look at du dx, the derivative of this with respect to x, it'll just be e to the x, because the derivative of e to the x is just e to the x. And therefore, we can rewrite this nicely as the u equals to e to the x dx. So therefore, we can rewrite this integral now as e to the x plus 2, obviously times there. We can multiply this and we can get that simply this will just be the e to the x dx. And then based off of this, we know that this entire part here will just be u, and this part over here will just be du. So what does that do? So what this does, it leaves us the following integral. So therefore this becomes u, the integral of u du. But we all versed by now at solving integrals like this. So therefore this becomes u to the 2 over 2 plus the constant of integration c. And I think what is important is to remember to substitute back what that particular integral is. So this becomes e to the x plus 2 to the power 2, and this becomes all over 2 plus c. And therefore, that is our solution for this particular integral. I hope this has made some sense. Let us deal with the next question. With the next question now, we can split this up and rewrite this as e to the 4x divided by e to the x plus 2 to the x over e to the x dx. And then from here, we will split this up. We'll simplify this. This is now the integral of e to the 3x plus this is the integral again of 2 to just e to the minus x, everything of dx. So we'll just be taking individual integrals of this. Just another reminder again, we can simplify this. This is the same as taking the integral of each of this. So I've got e to some function, so I need its derivative. So again, we will multiply by the unit factor. So this becomes the integral of 3 to the 3x, and we'll multiply by 3 because 3 divided by 3 is 1. So that's us just simplifying the question. And the next one, 2 is a constant, and therefore we'll rewrite this as e to the minus x, and we'll just take the derivative of that as a constant and just multiply by -1 dx. So once we have done this, we can simply go back. If I integrate e to a function times its derivative, then we are able to simply get that as e to the x when we integrate it. So in this case, this becomes 1 over 3 e to the 3x. I'll put the -1 there on the outside because it does multiply. So therefore, this becomes 2 e to the minus x and everything plus our constant of integration c. And that is how we'll be able to solve that particular integral. Let's do 2 more integrals that we can work with. Again, when coming to this one, if we have a denominator like that, we can see that there's a relationship that u is x squared minus x, and the derivative of u in this case will be 2x minus 1. It means that this question we've won, so therefore we can apply this rule that we have here. So therefore, I now have a u in the denominator function. I have its derivative in the numerator, and therefore we can easily work out what the integral is, and therefore in our case this integral simply becomes the ln of the function that is in the denominator plus our constant of integration. So this does make our lives a little bit simpler in us utilizing these rules that we have. So let's have a look at this next one here. Again, you can have a look at your denominator. If you let the denominator become u, this is 3x to the 3 minus 4. If you took the derivative of that, however, the derivative becomes 9x squared, and therefore you are missing in the numerator a 3. So we will then multiply this by a unit factor of 3. So therefore we can rewrite this integral now by multiplying the 3 in as 9x squared over 3x to the 3 minus 4 of dx. And therefore once we get here, we can apply this rule again. I've got u in the denominator, I've got its derivative in the numerator, therefore I can apply that rule again. So this becomes the ln of the absolute value of 3x to the 3 minus 4 plus our constant of integration c. I hope that doing more of these examples has helped you, and therefore I have now finished the series on doing the integration of exponential and logarithms. See you in the next video.